Hello everyone, welcome back to the channel. I hope you guys are doing really well. So we will see today's daily challenge on Leetcode and try to solve it together. So today's challenge, although does not use any kind of data structures, but it is actually intuitively difficult problem. Okay, so yeah, I will tell that if you are solving it for the first time or these kinds of problem, it should be definitely hard for you. So let's see and try to understand what the problem says, and we will try to simplify it down to as easy as possible. Okay, so let's see. So count the number of substrings with dominant ones. The problem statement is really simple. You are given a binary string, it consists of only zeros and ones. You need to return the number of substrings with dominant ones. Okay, and the definition of dominant ones is given that if a string has dominant ones, if the number of ones in the string is greater than or equal to the square of the number of zeros in the string. Okay, so you need to take care that yeah, you need to go through all the substrings. You might be thinking this at first. Okay, and then just select whichever substring has number of ones to be greater than or equals to the square of the number of zeros. Examples are very clearly given here. You can see that these many other substrings starting from I to j, and the number of zeros are given, the number of ones are given, and number of ones are greater than or equal to the number of zeros. Okay, so also for example 2 it is given. You can go through these examples, and yeah, but I hope the problem statement is anyways clear to you. Problem statement is very simple, and yeah, does not have any doubt in this. Okay, now you see, if you try to think what should be your first thoughts in this approach. Okay, so at first you will look for n. Okay, it's 4 into 10 to the power 4, so even an n square solution is not allowed. You need to do something better. And if you see, if you try to see, if you want to go through all the substrings, right, if you want to go through all the substrings, it will definitely take an O of n square solution, and this should be your first approach. Okay, and you might end up in thinking that yeah, this will be very difficult because the zeros are, or the number of ones or the number of zeros are definitely of the order of n. Okay, if n is the length of the string, they are of the order of n. But you should see one constraint in this problem is the number of ones should be greater in your substring. Okay, so what are our in your selected substring. Okay, so in your possible substring, you see, if there is 1 0, if there is a single zeros, okay, then what is the square of 1? Number of ones should be greater than or equal to 1 ones. Okay, now if you see, if your substring has 2 zeros, number of ones should be greater than or equal to 4. Similarly, if you go on seeing that my 0 is increasing linearly, but my number of ones has to be greater than or equal to the quadratic value of the linear increment. Okay, so whatever is the linear increment here, the quadratic increment it will be the number of ones. So what is this? And you see, zeros and ones, in fact zeros and ones, both of them are actually making up the whole length of the string, you see. And one is of quadratic nature, one is of quadratic in nature. Okay, so I hope you do understand something from here. So the constraint portion is 0. Okay, the constraint portion in this string is 0. So you see, we can, if you also want, you can do a little bit of calculation with this. So let's say your total number of zeros and total number of ones would make up the whole string n. Okay, and it was told to you that the number of ones, what are the number of ones? It is n minus z. Then this should be, this whole thing should be greater than, this number of ones should be greater than or equal to the number of zeros. Okay, so square of the number of zeros. So yeah, this should be the case. So this kind of inequality, I hope you do understand, that you get it. And if you now try to see one thing which can come to your mind is that let's try to, what if we try to solve this inequality. I hope you can solve it, right? Because this is a simple high school problem. I don't think there should be any difficulty in this. Yeah, this much mathematics, I guess, yeah, everyone knows. So yeah, we have it. We will try to apply the quadratic formula over here, and you will get something like z is less than equal to always the z max value, okay, and z max will be nothing but so minus b plus minus under root uh, b square minus 4ac by 2. Okay, I hope you know all this. So one thing you easily get to know that z, the number of zeros is in the string, is highly constrained. It is not as large as the number of ones. So the number of zeros in the string should be constrained, and it should be less than or equal to this value, 4n under root 4n plus 1 minus 1 by 2. So you can also tell that the number of zeros should be of the order of O of root n. You can also say this, okay, or whatever be the case. You do understand that number of zeros is of order of root n. So yeah, you might be thinking that in your string of length n, some are zeros, some are ones, okay, but in your possible substrings, if you are going to calculate, this number of zeros should be of the order of root n, and definitely although zeros may be of the order of n, what you need to iterate uh, is of the order of root n, okay. So the thing what will happen by you doing all this, you might ask that, hey, you calculated this, you applied some formula. I hope you know this formula, quadratic rule, okay. So what will happen by doing all these things? You got to know few observations, okay. Observation 1, 0 is more constant, okay, and definitely an idea hits up in your mind when you look at this observation, is that why not iterate only through zeros? Why not iterate only through zeros? Do you understand what I am trying to say? See, if iterating, you see, all the zeros takes root n time, then why not just iterate through the zeros? Now you might be telling that, hey, what are you telling? In a substring there is a starting point, and there is an ending point, okay. Now you select any of them. In my example, I will choose to select and start ending point, okay. So I will try to iterate through my ending points. So I will try to, let's say I have this string, I have this binary string, okay. I will tell that, like, I will have an iterator I, which will, let's say, go from 1 to n or 0 to n minus 1, whatever. It will, in whenever it will point to the ith value, it will tell me that what if it is ending at this point and starting at some other points. Now the starting points I will take to be I will only iterate through the zeros, okay. So what I am trying to say is that you might think that, hey, it will also give it n square, but it will not. Why I am trying to see, yes, you see, that's so let's say you have a 1 over here, you have some 1 over here, this is the 0 you are having, and there are some other zeros. So some zeros you are having in between, right? Yeah. So what I am trying to say is that what we will see, suppose your I is somewhere over here, okay, or even if it is somewhere over here or somewhere over here, you will see, let's maintain some pre-computation by which I will, in O of 1 time, I will be able to know where is my previous 0. In this index there is my previous 0, okay, and I will only iterate through these zeros. And since I have all these indices of zeros stored, I can also tell that how many ones are there in between. And since I am at a starting at an index of I can tell that, hey, I will go to the this I will be my, as I told you, I will be my ending point, right? To determine my starting point, I will go to the this previous 0 at first, okay, and this previous 0 wherever will be the index till this to the previous plus 1. So let's say this I will maintain a previous array. Okay, so previous of I will give me where is the 0 just before this, in which index number. So previous of I will give me which index number is 0 just before I. Okay, so let's say that index number is this. Then after that, let's say there are more ones in between, right? Let's say there are more ones in between. So you see, you go to the index number of the 0 which is just before this, and plus 1, you go plus 1, and you can say that starting from that to all other elements there will be just 1, and I can easily say that if my valid starting point is this, let's say my starting point is this, and you see the criteria actually holds true between this starting and ending, then you can also say that if this was the starting, if this one was the starting, or any of the ones in between these zeros was the starting point, there would have been no problem, because my ones are getting incremented, and that can be as much as possible. It should be at least greater than or equal to the square of zeros, but it can be as much as possible. Okay, I hope you do get what I am trying to say. So what I will try to do is maintain a previous array. So how I will do that array? So I will first try to write that array and also go on explaining. Okay, so I'm just not starting to code, but yeah, I will just create that previous array, and I do have many other things to say. So we have this s dot size, and let's keep a vector previous. Okay, and let's call it n plus 1 minus, let's initialize it with -1. Yeah, we are anyways going to just initialize all of them, I plus plus. Okay, and what I will do is that if I is 0, or if string of I minus 1 is equals to 0, what I can do is, see, this I am taking plus 1 just for the sake of easy calculation. You will understand why I am doing this. Previous of I plus 1 equals to I. Okay, and else previous of I plus 1 equals to previous of I. So if there is a 0, if there is a 0, we will call that hey, this is the point where this is the index number where there is a 0. Okay, otherwise we won't call that. So I hope you do understand how will my previous look like. So if there is something like this, let's say the index number of this is 0, 1, 2, 3, 4, 5. So it is storing the sort of index number. Okay, so you can say that the first 0 is occurring at this index. Okay, then at index I you want to check that which is the index number which just occurred before this. So this is also 2, then again it will be 4, and 4 will be continued. Okay, something like this. I hope you do get it. If there is a 1, again there will be 4, but if there is a 0 now, the index number will change to 7. So at any point you can tell, even if you are at index 6 or index 7 or index 5, you can easily tell in which previous, what is the previous index where 0 is stored. So it tells you that at index number 4 0 is stored before this. Okay, before this also you can check. I hope you do get it what I am trying to do. Okay, so yeah, that is the idea over here. And yeah, this kinds of idea will not come to your mind directly. Yeah, you need a lot of practice and stuffs like that. Definitely you will be able to do this. As of now, you can just take these ideas and just store it in your mind. These are the possible things you could do to solve the problem. Yeah, so let's say you have an integer answer, okay, which you will calculate. So yeah, that will be the total number of substrings, and you see I will try to iterate from, let's say, I from 1 to n and I plus plus. Okay, so what I will do every time, as I told you in my explanation, is that I have a binary string. I will go through the ending point. I will start with, let's say, I equals to 1 to I equals to n, and I minus 1 only I will iterate. Okay. So when I am at a particular index, when I am starting at a particular index, it would mean that this is my end point of the substring, and for the starting point, I will, from every endpoint I will go back and hop through all the zeros. If there are zeros and ones present in between, I will hop through all the zeros. Okay, and that will be of the order of root n. Whenever I am seeing that my order of the zeros is increasing than root n, then I will stop iterating. Okay, that's how for every element. So even if I iterate I n times, from a position I am going backwards only root n number of times. So that will be my n root n time complexity. Okay, that's what I am trying to do. Okay, so I hope you do get it. So basically, this will be, I will be my end point. Okay, so I is nothing but my end point, and j will be my starting point. But what will I initialize this j to be? Initially this j will be I. That is quite obvious, because yeah, I am iterating backwards from I. Okay, and my starting point I will start with j. So I hope you do get it right. So j will be my starting point, I will be my ending point. Initially j will be equals to I, and it will hop through all the zeros and go backwards and tell me that what are the possible starting points. So that is what. And you see, what will be the count of the total number of zeros? Initially, if my current string, so count 0 I will call it. Okay, and so basically I will, this is one based indexing, right, I am doing. So if you can do 0 based also, whatever you will feel like doing. So yeah, if I s of I minus 1, if it is 0, then I will put count 0. I will initialize some count. Okay, so let's say I have this int count of the total number of zeros to be 0. Okay, or not initialized anything. Then if it is 0, the count 0 is how much? Then starting from it's 1. Okay, because my current index from where I am starting, that is only 0. So I have the count of the total number of zeros to be 1. Else initially I have 0 zeros. Okay, and now I will try to use a while loop. What will be the criteria for the while loop? Definitely my starting point is j, right? So j I was my ending point of the end point of the substring. Okay, in case you are forgetting, and j will be my starting point of the substring. So starting point of the substring. Okay, so definitely while j is greater than 0, I will keep iterating j and I will hop through the number of zeros, but I will make sure that I am going through at most root n number of zeros. So count 0 into count 0 less than equals to n. So I will make sure that this criteria is getting satisfied. Okay, uh, otherwise I will stop iterating, otherwise I have to definitely stop iterating. Okay, and you see integer count 1, what will be the number of ones? Can you tell me? Can you, hey guys, can you just tell me what will be the number of ones? Can you tell that let's say I am at my starting point. Okay, uh, starting point is j, ending point is I. Okay, now the point at which I mean, can you tell me that previous of j will tell me that just before this where is the 0? Let's say 0 is somewhere over here, in between there are all ones, right? So previous of j tell me that at which index number 0 is there. Okay, so count of the number of ones till those, I am considering all those substrings which are starting at this one, this one, this one, this one, this one, this one. Okay, because I am hopping through the zeros, right? So what is the total length of the substring? Length of the substring is easily I minus previous of j. This is the total length. Okay, and what is the number of zeros? Number of zeros is CNT 0, so number of ones can be easily calculated from len minus cnt0. I hope you can get it easily, right? So that's what I will try to do. Count of 1 will be nothing but len minus total length of the string substring which I am considering minus count of total count of zeros, and this is nothing but I minus previous of j. I hope this is very clear to you, at least count of the number of zeros, and every time as I am hopping through the zeros only, I will make this j equal to let us say previous of j. So yeah, I am hopping through all the zeros, and yeah, when I am getting a new zero, my count of 0 will also increase. Yeah, so I need to update my result, right? Now what will be the number of strings? You see, if the criteria what I am looking for is satisfied, then only I will choose to add something into my answer, right? If this criteria actually satisfies that count of 1 should be greater than or equals to the count of zeros in my current substring, then only I will choose to add. And you see, how many substrings are we going to consider? How many substrings, how many starting points of the substrings are we going to consider? So let's say this was the previous of j, which is just giving me the index at which the last 0 occurs. I am considering such starting, I just now told you that I am considering that this is the starting point, this is the starting point, every element has our starting points. So what is the number of substrings you will get? You will get it j minus previous of j. I hope you do get it, do not get confused, right? This is the previous of j, this is the previous of j, and this is the j. You are getting, you are considering the starting points of all of them because they all contain the same number of zeros. They all contain the same number of zeros but different number of ones. Okay, so result plus equals to will be, you might be thinking that hey, why not add j minus previous of j? Why not just do this? But do you think doing this all will make sense always? You see, you did not even take care what is the count of ones. So uh, one thing should definitely be true is that the count of zeros, so basically what I am trying to say is that the minimum allowed length, what is the minimum allowed length? It is count of 1 minus count of zeros into count of 0. Okay, this is the allowed length at least. Okay, I mean at the point where count of 1 minus count of 0 into count of 0, I mean where this is greater than or equals to, so it is just 1, just greater than 1, then only you need to clip the value, right? So you just clip the value either in either of the cases, right? So minimum of this is basically the maximum allowable thing which I am going through all of the substrings, right? So I am going through all the ones, I am considering all the starting points of this substring, and the minimum allowable length. Okay, so what was the allowable length? It was count 1 minus count 0 into count 0 plus 1. Okay, so yeah, yeah, that was the thing, and if you try to return answer, I think it should just work fine. I hope this problem was clear to you actually. Yeah, so this is not result, I wrote it as an answer, right? So yeah, I know this problem is actually intuitively hard, and yeah, but I hope at least you tried to understand. If you did not understand, definitely ask me in the comment section, or I will also suggest to listen each and every word of the video what I say, and try to follow it again. Okay, if you are confused any point in between, because yeah, I do understand in a 20 minutes video, I mean, you might get lost, especially in this kind of problem if you have not done similar things before. So yeah, it might be very difficult, but yeah, at least try to understand, and I hope you will do good one day. Yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.